There we go. Sorry about that. Dissociation. Anybody look at that word and guess what it means? What word does it sound like? Association. What is association? Like doing something with somebody else or two things that are together. So what do you think dissociation means? Very good. Pulling things apart, separating things. Okay, so dissociation is what happens when you have what's called a reversible reaction, which means a reaction that can go in either direction, and you take a particle and pull it apart. So it can actually happen to water. If you dissociate water, it goes into two ions. It goes into a hydrogen ion and a hydroxide ion. Okay, hydrogen ion, pretty straightforward. Hydroxide ion is what OH negative is. So we're going to be talking about both those guys today a bunch. Now, this is also, what did we say about water yesterday when it came to pH? What is water? Is water an acid or a base? It's perfectly in the middle. And the reason it's perfectly in the middle is because to be an acid, you're going to make more hydrogens. Acids give you hydrogens. That's why they corrode things, because that's why they break things apart. Bases give you hydroxides. Okay, so water, when water dissociates, it gives you both. So that's why it's perfectly neutral. For every hydrogen it gives you, it's going to also give you a hydroxide. You can never have more of either of those things when you dissociate water. So water can never be an acid or ever be a base. Okay, so let's look at a couple other things. What do you think you're gonna get when you dissociate that? A H and a Cl. So this guy right here, you would guess is a acid or a base. It's an acid. This is hydrochloric acid because it gives you hydrogen, right? What do you say? Hydrochloric acid is absolutely stomach acid. Very good. Okay. Check out this guy. It's going to dissociate into sodium and hydroxide. So is this guy going to be an acid or a base? It's going to be a base. And bases you just call what they are. Sodium hydroxide. Anybody know where you can find sodium hydroxide? Probably not many people in here. Maybe one of us knows it pretty well. But it is in a chemical that relaxes your hair.
Hairspray.
No, the opposite of hairspray. Hair relaxer. Relaxer, straight, exactly. White people are like, what? Okay, y'all help me out of it. All right? Hair straightener, relaxer, perm. Okay, to get your curly hair to be long and straight. Okay, sodium hydroxide does that. That's why when you leave it in too long, it could burn. Okay, sodium hydroxide is those OHs in there that are breaking apart the little molecules of your hair, making it straight. And also, if you leave it in too long, can start doing that to your skin and start to burn. Okay. Sodium hydroxide, NaOH. If you're curious about that and want to learn a lot about it, there's a really good documentary Chris Rock did about 10 years ago called Good Hair. Go watch it. It's good stuff. Right. But sodium hydroxide, hydrochloric acid. Acid because it gives you H's. Base because it gives you OHs. Make sense? Okay. Now check this out. When you mix these two things together, it's called a neutralization reaction. We're mixing an acid with a base. It's actually going to be remember, this is taking it back a little bit, it's going to be a double replacement reaction. So the hydrogen is going to come over here and replace the Na. The Na is going to come over here and replace the hydrogen. So we end up with NaCl, which is sodium chloride, which is table salt, and HOH. What's another way I can write HOH? Flip it around.
H2O.
Very good. Anytime you have a neutralization reaction, you always get an ionic compound, a salt, and water. Neutralization reaction, if you mix an acid and base together, you always get some type of salt and water. Okay? So let's look at these reversible reactions a little bit again. Let's look at the hydrochloric acid. Man, we teach in school right now. Why are you calling me? Hello? Okay. We're rocking and rolling. Yes, ma'am. I appreciate you. Yes, ma'am. Have a great day. All right, let's rock and roll. So we got HCl. We're going to dissociate into hydrogen and chlorine. Now, this is what you call an equilibrium. When you have this reversible reaction can hit equilibrium. You put hydrochloric acid in water, part of it dissociates into H's and Cl's, and part of it stays the solid hydrochloric acid. Okay? Now, what you can do is you can change this, you can shift this reaction. You can shift this reaction by adding something to one side or the other. Okay? And it's pretty straightforward. It's pretty easy to understand. When you have an equilibrium, if you add something to one side, it's going to shift the equilibrium to the other side. Okay? So if I add hydrochloric acid to this system, it's going to create more stuff on the right or the left. Is it going to make my reaction go faster that way or faster this way? Which side is hydrochloric acid on?
What?
It's on the left, so it'll push the reaction
That one.
to the right. If you add hydrochloric acid, it'll shift it to the right. If you add hydrogen by itself, it'll shift it back to the left. And it just does the opposite when you remove. Let's say you have some type of machine that's pulling hydrogen atoms out of the water. So you remove hydrogen atoms. Since you're removing the hydrogen atoms, that creates less stuff over here, so you're going to shift it that way. If you add something, it pushes the equilibrium away. If you remove something, it pulls the equilibrium towards where you want to go. Okay, let me give you another example of that. I'm trying to remember my formula. I think it's HCO3. I'm going to cheat a little bit. Sorry about this, guys. Give me a second. I don't want to screw the, this is in your notes. If you ever want to look at the notes, the formula I'm about to, well, it's up there. You guys like listening to me talk, but the people at home might be wanting to look at the notes. It's called the Chatelier's principle. There's the formula. I was going to do it wrong too. Good thing I looked. Equilibrium here. Now this one doesn't have anything to do with acids or bases, because neither one of these things are acids or bases, because you got no hydrogen up there. Okay, but this is a reaction. Let's check this out, and you can tell me. I'm going to tell you what each thing is, and you tell me where you think this is happening. Calcium oxide, pretty straightforward. Carbon dioxide, and this is calcium carbonate. Calcium carbonate is the most common ingredient in eggshells. So where's this reaction happening? No. Where's this reaction happening in the world?
Yeah, eggshells.
In a chicken. Okay. This reaction is happening in a chicken. Okay. Let's think about what's going on here. Where's carbon dioxide coming from? Air. Where's calcium oxide coming from? Their food. Exactly. Their food. And then the product is they're making those eggshells. Now, we have a problem here. Because in the summertime, In the summertime, chickens get hot. Now, chickens don't sweat because chickens don't have sweat glands like me and you do, like mammals do. Okay, so chickens, one of the ways that they cool themselves off is by panting like a dog. I know it seems kind of weird, but chickens will actually go and pant like a dog. And when they do that, their blood dumps carbon dioxide. So when carbon dioxide goes down in the summer,
The amount of eggs they lay goes down.
well, it shifts the reaction to the left and it makes them produce less CO3. So it's not that they lay less eggs,
They're into more fragile.
it's that the eggs are soft. The eggs don't have much calcium carbonate, so you end up with very fragile eggs. Now, what's the problem with fragile eggs? Because it shifts this reaction to the left. Yeah, they break. And if you're running a factory farm where you're making a whole bunch of eggshells, why might that be a problem? Exactly. Okay. But so that's a problem. So so you're the farmer. You don't want to have fragile eggs. How can we fix this problem?
Put carbon in the food. Boy, cool the chickens off.
Okay. Both of your strategies are excellent. Okay. The problem with cooling the chickens off is very, very expensive.
Maybe have a
Okay.
season, like certain seasons of they have the chickens.
Yeah, but you want to sell eggs all year.
Put
Okay.
a big HC unit.
I like the big AC unit is too expensive.
Yeah.
So go back to your first idea.
Put carbon in
Put what in their food?
carbon dioxide.
Well, carbon dioxide's a gas. How are you gonna put it in their food?
Put CaCO3 in their food.
Well, CaCO3 in their food,
Actually, calcium.
you want to put that guy right there in their food.
Calcium.
Okay, so when you increase calcium oxide, that's going to shift it over there and give them the eggshells, but there's actually a cheaper thing you can do. You're on the right track. Say it out loud so other people maybe can throw the answer out.
Carbonate water.
Give me a better, can somebody say that better?
Carbonate.
Yeah, give them bubbly water. Yeah, and so like when they feed chickens during the summer, anybody seen like the thing that makes the Pepsi at home, what's it called? Yeah, it's like it makes your water bubbly. Yeah, you know that's what I'm talking about. I can't remember what it's called. What's it called? I can't remember what it's called. But you can buy it at Bed Bath and Beyond. They sell the stuff that makes the water bubbly. Okay. What? No, not that. Y'all talking about a bath. I'm talking about do you drink? Not like I know. What's it called?
No, you don't get that shit Bed Bath & Beyond.
Make your water carbonated.
I can't spell carbonated.
There's a little fresh thing.
Soda stream.
Yeah, soda stream.
Is it where you get it from?
You can get it at Bed Bath and Beyond.
You sure?
I've seen them.
That's everything.
Not the thing in the mall, the one next to Marshall's and Michael's and Rose.
Yeah, not Bath and Body Works.
Bed Bath & Beyond literally has
Bed Bath
everything.
&
Oh.
It's by Best Buy.
Yeah, it's that thing.
Soda stream. So what they do is they take this little thing. It's not, they don't use soda streams, but they get a big machine that all of the water their chickens drink has carbonation in it. And if they do that, it shifts this reaction back that way because you're adding carbon dioxide, shifts it back that way, and you have stronger eggshells. So we'll talk more about this tomorrow, but that's the main thing is we need to understand equilibrium. If you add something to this side, it's going to shift it to the opposite side. If you take away something from this side, it's going to shift it back to that side. Make sense? Let's calculate some pH.
Oh, crap.
Okay. Yesterday I told you that pH is all about hydrogen concentrations. Okay, so how you write hydrogen concentrations is with brackets. So what that means is your hydrogen concentration. And it's usually a very, very low number. Very low number, something like 2.3 times 10 to the negative, let's say 4 is your hydrogen concentration. Okay?
That's a lot.
Okay, that's a really low number, so it's 0.00023. Okay?
That's a lot.
Molar.
Yeah, that's a lot.
Okay. So 2.3 times 10 to the negative 4 is my hydrogen concentration. The formula I'm gonna put your formulas over here, but I'm gonna put them over here so they stay there. The formula to go from hydrogen concentration to pH is negative log of your hydrogen concentration gives you pH. Okay, so I'll write it over here so we know it. Negative log of your hydrogen concentration gives you pH. Okay, so let's everybody, I told you grab a calculator, right? So let's check this out in the calculator. Pretty straightforward. Okay, so you just hit the negative button, which is beside the decimal. Then hit the log button. The log button is going to be, yeah, under the second. The black number under the second. So second button from the top all the way to the left. So negative log. Then you type in this number 2.3. Remember E. 2.3 E negative 4.
Oh, what? How do you put the E in there?
That's second above the 7. So this is what it should look like on your screen.
So it'd be E negative 4?
Yep.
Just E negative 4.
You don't need to times 10 because E is times 10.
Do you close your parentheses?
Close your parentheses because it'll give you error if you don't.
So 3.6.
Smash your enter and give me maybe 2 numbers past the decimal.
3.63.
3.64 if you're round. I'll give them both right. So we're talking about an acid or a base.
Talking about an acid.
Very good. Make sense?
No.
Okay. Now, your practice today is all about these calculations, so I'm not going to do too many of them. I'm going to kind of let you do them. But we got to be able to go back. We got to be able to go back. And how to go back is just you do the opposite of log. Now, look on your calculator. Everybody see the log button?
Yes.
See the second button above the log?
Yes.
Okay, 10 to the x. The reason that they did that on the calculator is because that's the opposite function of log. So if you want the opposite way to do this, it's 10 to the negative pH equals your hydrogen concentration. So let's try and see if it works. Let's try and see if it works. So hit that second log button. So second log, and your calculator screen should look like this.
You put 3.64 in there?
Like that. Then you put 3.64 in it. It actually is negative. You got to put negative. My bad.
Negative 3.64?
Yeah.
Man, that's crazy.
Yep. Sorry about that.
You have to put negative behind the 10.
Yeah, I put a negative there. I was right. Sorry.
Which one?
That's it. Yeah. Negative 3.64. You in the parentheses.
You get 0.00022.
Is that the same number?
Yeah. Dang, that's crazy.
Everybody feel good? Okay. Well, we'll practice some. But we got one more thing we got to do before we practice. Because what if instead of doing this, I give you this? This guy is called the hydroxide ion concentration. And let's say my hydroxide ion concentration is 3.7 times 10 to the 6. Well, actually, let's do 10 to the, 10 to the 6. 3.7 times 10 to the 6 is my hydroxide ion concentration. Now, here's what's cool. The hydroxide ion concentration formulas are the exact same as these, but instead of going to pH, so instead of negative log of OH giving you pH, what do you think it gives you? Huh?
Gives you the one.
Remember, H gave me pH, so OH is going to give me. Let's use your common sense, guys. Use your common sense. If H gives you pH, OH is going to give you POH.
Oh.
Okay? So instead of a pH, this is going to give you an answer that is a POH. So let's try that real quick on your calculator. So the calculator screen will say negative log, and then 3.7 E6. Oh, it's negative, should be negative 6, my bad. Smash the enter button on that, see what we got. Yes, sir. Second above the 7. It says EE on your calculator screen. On your calculator. Well, stick with me, buddy. That's why I'm with you.
I got 5.431.
5.431, so 5.43.
Yeah. That'll work.
Now, that's your POH. Now, I haven't talked about POH yet. It's the mirror image of your pH. And here's your easiest formula that you're ever going to have in chemistry class. How to go from pH to POH. Now, what's my magical numbers with pH? 7's in the 7 is where on the scale? Right smack in the middle. The other important numbers are
Like 1, 4.
not 1, 0, and 14. So if pH and POH are mirrors, any guesses on what this is going to be?
Wait, mirrors.
Yeah, if they're mirror images,
They would say things.
if you add them up, you should
No,
get.
it'd be like 11,
No,
or 10.8.
no, you're thinking too hard, brother.
A mirror is like it mirrors itself. That makes it. It's just itself.
No, you're thinking. Okay, maybe mirror is not the best word. Evil twin.
Evil twin, like a
Okay.
doppelganger.
Yeah,
They
like
cancel out.
it's similar but opposite.
They cancel out because it's negative.
So if I add them together, what number are we getting to?
0.
Nah,
That
because nobody's negative here. 7's on the right track.
7.4.
I said it's on the right track, but you got to go the rest of the way. 14.
Yep. What?
So if my pH is 5.43, what is my pH? Excuse me. If my POH is 5.43, what's my pH going to be?
8.57.
Feel free to use a calculator on that as well, guys. Okay. So I'll throw that up here. Yeah.
Don't ask me.
Like I said, a stupid question. So is this guy an acid or a base?
He is a bait. Wait.
And you know that why?
It's above 7.
Because they're both 7. Okay. So you can give me from the hydroxide ion concentration or the hydrogen concentration, you can tell me whether or not something's an acid or a base, right?
Yeah, sure.
Okay. So, I mean, I'll put the rest of those formulas up here, but really, if you know these two, you know the other two because they're the same. So negative log of OH gives you POH, and 10 to the negative POH gives you OH. So I'm going to leave these up here. But even though it looks like there's 5 formulas, there's really only 2 because the pH plus POH equals 14 is easy, and the other 2 are just the same as the first 2. Okay, let's look at your practice for today, do a couple together, and then I'm going to set you free. Well, that thing's relatively dry, so you're good on that.
Yeah.
All right, so I'm bringing up the practice. Now, if you look at the practice today, here, I'll bring it up so everybody can see it. Practice today is this big chart, okay? Practice today is this big chart, and you can actually do it on Google spreadsheet. I think if you click on it, or you can transfer it to Google spreadsheet if you get fancy.
I'll do it.
Okay, but you can just copy it, put it on Google spreadsheet, and then just put in things. Let's do it together so we can all work together here. So just select it all, then bring up your Google Docs and open up, create a spreadsheet and paste it.
The first time I ever used Google Sheets. Wait, we're using Sheets or using
Yeah.
Docs?
Now you want to use Sheets.
Yeah, because it's fun.
Paste. There we go.
No,
That worked.
like that's funny.
Okay. So now here's what's cool.
How does that work?
If you get any of these 4 things, look at, they're all kind of different. Each one gives you either pH. H3O is the same as H. Don't let that confuse you. H3O, if you actually want to change it on your thing, it's fine with me. It's Mr. Sleepy being fancy with hydronium ion. Okay? So it either gives you pH, H, POH, or OH. And from that, you can say all of the things. So let's start off with the easiest question. pH is 3.78, acid or base? Acid.
I just write acid.
Yep. Or A, I don't care.
Acid or base?
Oh, it added it to it.
Yes. No, it didn't mean
Okay. All right. The next easiest thing, in my opinion, is to take 3.78, subtract it from
14.
Put me up.
Can't do math. Do it backwards.
I'm gonna actually write it so you can see it a little bit bigger. Let me zoom in.
Why did it 10.22?
Oh well. 10.22.
Yeah.
Sounds good to me.
Where did I go?
All right. Where POH is. Okay. Now we got to do our negative logs because we have both of these, and we want both. Actually, I'm sorry. We have these, and we want. We have these, and we want these. So we do 10 to the negative pH to get the H, and 10 to the negative POH to get the OH. So let me just go whatever you need to do to go to each spot. So we have this one right here, 3.78. So I'm gonna type in that 10 to the negative, and then 3.78. I'm gonna smash the enter button. And if you want to get fancy, change the scientific notation so it'll be easier to read.
I do it.
Second SCI
So we're
at the
supposed
top.
to do second log. Get 10.
Second log, 10 to the negative 3.78. Close parentheses, add the enter, change the science, make your life easier. One number past the decimal is fine with me, but if you want to do 2, you can do fancy.
So it's 10. I changed the sign and made it silly.
10 to the negative 4, right?
Yeah. 10 to the negative. I put that over H1 negative plus H1.
And then your OH, you're going to do the same thing with 10.22. So if you want to go on your calculator and just where you had done the negative, just go 10.22. Smash enter.
What's your POH is 10.22?
Yep. So this fool right here, 6.02 times 10 to the negative 11.
What? How would
Right?
you put that?
Or 6.03 actually. What you do?
How did you get 6? How would you put
10 to the negative that. 6.02. What?
Okay.
Speak up, Josh. What do you not know? I don't understand what you don't know.
It was confusing.
It's confusing. You got 4 formulas where you do what you need to do to go where you need to go. 5 formulas. And you just roll on.
How we put 6.02? What do we put like 6.02? And then are we here?
How you type it in, I don't care. Make it pretty. I don't care. Do it however you're comfortable doing.
6.02 times.
You can put E if you want to. 6.02 E negative 11. Follow me.
E negative 11.
Yeah. Like literally what's on your calculator screen.
That was a 4.
I give you a little hint. No, the 4 was over here. I give you a little hint. If you did it right, your exponents on your OH and your POH always add up to 15. I don't know why that is, but they do. That's a mathematical weirdness.
Pretty cool.
Do the next one, and I'm gonna roll on. All right, so the next one, you got your H. I want my pH. Which formula? If I have my H and I want pH.
Negative log and then the H equals pH.
Very first formula, right?
Yes.
Okay. So negative, hit your log button, 3.89 E negative 4. No, it's not negative. 3.89 E negative 4. Smash your enter button. And then how do you find a POH from that?
Subtract that from 14.
Let's do it.
You find out
You get 11. No, 10. 10.59.
And then how do you go from POH to OH?
Oh, that's your question.
What?
It's the same thing we just did here.
How do you get POA from pH?
14 minus that. That's one of the easiest things. You can just go down the line and do that without even having to think.
You would do 10 to the negative POH equals OH.
10 to the negative that fool.
So you do log.
Second log.
Okay, so second log.
Negative 10.59. Smash enter.
2.57.
Don't forget your times 10 to the negative 11.
Okay. Is it
2.57.
always going to be times 10 to that? Yeah.
It's going to be times 10 to the whatever.
Yeah.
Okay, sometimes it's negative 11, sometimes it's bigger, sometimes it's smaller. 3.41 is by pH. We talking an acid or a base?
Acid.
Rock and roll. All right, carry on. And this seems like busy work, I'll be honest with you, but this is practice, man. You got to get good at this stuff. It's just a matter, it seems confusing because you haven't practiced it. It seems easy to me because I've been doing it for freaking 20 years. So carry on, push the buttons. If you get stuck, I'm here for you. You got 5 formulas to use. If you don't